Any questions, any thoughts, anything?
Who wants to go first? Bushnell, you want to go first? Maybe
I could chime in. I could chime in, Chantal, even
Thank you. Go ahead.
Even as we begin. The one reflection really for me is how these concepts become or translate to effective TLMs, or rather are integrated into TLMs, because sometimes it's one thing to have all this knowledge, but then being able to translate this knowledge into not only learning experiences, but also how to integrate them into textbook development. And just this morning, I think Chantel and Leah and myself were looking at some sample textbooks and just discussing and reflecting on some of the things you were talking about. The connections between the concrete, the pictorial, the abstract, and just being able to see how much that is missing in some of our national textbooks when compared to other, high quality TLM. So I think it's something that really one has to consistently think about when we are getting into this entire, space to try and influence learning outcomes.
Thank you, Virginia. Definitely agree. It is much, it's all of these ideas are great, but how you create a learning experience that you can convey to a teacher that may not have the same knowledge is really difficult. Thank you, Virginia. Definitely agree. Anything else? I think let me just look in the chat. It's all of these ideas. Some subitizing. Well, you've been using some subitizing. Great. Joy, still thinking about subitizing. Have the same knowledge is really difficult. Taking numbers for granted. I like that, Lydia. That's a nice way of putting it, because so many of these early math concepts, it's so easy for us, right? We're adults. We say, oh, of course, 4 is 4. Of course, 10 is 10. But looking at it from a child's point of view and thinking, it's actually pretty complex. That's a nice way of putting it, because okay, unless there's anyone else that would like to share, I'm gonna keep going. It's so easy for us, right? We're adults. So we're gonna start today with, did you want to say something? 10 is 10.
Absolutely.
Yeah, thank you.
So thank you very much, Yasmin and my fellow classmates. I'm happy to be back again here for another great lesson. Well, what I can say about the last lesson that we had is that it offered great insights into mathematics. And some of the things that we never took seriously, and we thought, like, when you are an adult, you even forget that there is a time when you also had difficulties with numbers. And that is the truth. When you become a grown-up and you see a child not being able to do the number work, you might think that, like, they are, they're not serious, they're not getting you. And some adults will get to a point of even being bitter with the children. But when you understand these basic concepts in mathematics, then you get to understand that there is a lot that goes on in a child's mind. And therefore, the lesson, last time, it was a humbling opportunity for me to come down to the level of the learner and try to understand, why did this child make this mistake? You see, I really want to understand. I want to sympathize with this child and then see what is the best way that I can be able to help this learner. Therefore, the session, Yasmin, was a great one. And I'm hoping that the teachers in the room like me we are going to carry this experience to our teachers when we open our schools early next year, so that we'll be able to help these learners by first understanding why they behave the way they do and what we need to do to help them come to that level of understanding and be able to understand the number concept in their mind. So it was a great lesson, and we are looking forward to another wonderful session. Back to you, Yasmin. Thank you.
Thank you so much. Very, very eloquent, very well put. So I appreciate it. And thank you for that reflection. So basic addition and subtraction. So let's start with this little vignette of a teacher giving a problem to a student. And again, let's put ourselves in the mind of the student. Why do you think the student said 4? What does this mistake tell you about the student's knowledge of counting? What would you do to support this student? Would anyone like to share?
Well, Yasmin, from my view, I think the learner might have confused whether this addition or subtraction. And in this case, the learner subtracted rather than adding. So it's the issue of language, wording, and the application of the signs. Yeah.
Yes, thank you. So we can see that what most likely happened is the student did the calculation of 6 minus 2. Why do you think the student did subtraction? Yes, go ahead. I think who is that? Elizabeth?
All right, thank you. I think it's because we normally subtract from something. So that something was not given. So whatever was given as 6, the learner took it. That is where we are subtracting from, because we don't subtract from, we just subtract from some, there must be something that we're subtracting from. I think that is what really confused the learner. Thank you.
Thank you. Thank you for sharing. Anyone else? Language. Yep. I think, Eric, that is definitely true. A lot of learners struggle with language. Walter?
I just raised my hand when the response I wanted to give has been mentioned. I also think the problem is language. They might not know what Fatima eating means. So maybe for them, they were like, Fatima had 6 mangoes and then she ate 2. So that's why they ended up subtracting.
And this problem, we often see this problem in the early grades where you say, oh, she ate 2 mangoes. She had 6 mangoes. She ate 2. How many does she have left? Right? That's a very common phrasing. So what often happens with word problems is that students don't pay any attention to the words. They see the numbers, they hear the numbers, and they do something. They add, they subtract, doesn't matter. Right? So the student knew that there's a 6 and a 2, but they didn't understand the rest of the problem. They didn't understand what is being asked and what the whole, premise of the problem is. So, sorry. Oops, let me go back to that. I went the wrong way. So yeah, just to keep in mind, word problems, we use these types of problems often as story problems to introduce addition and subtraction, but also keeping in mind students have language. A lot of you have said this, may not understand the language. They may not understand the word problem. Some of them may understand the language, but still may struggle with the actual word problem, right? So there's lots of different options here. But yes, so just to think about that. Let's go on with the story problems. And I'm going to ask you guys, so I'm going to give you a problem. Here's a problem. There were 4 children playing football and 5 more joined them. How many children were playing football altogether? And what I want you to do is to think about this problem and think about how do you think a child would solve this problem? What do you think a child would do here? Maybe somebody can show us what they think a child might do. And this is where you might need your counters.
I was trying to open my video, but then it failed. I don't know why. But I feel like some of the children can just do this. Like maybe the teacher says this problem, and then the child will do it mentally. Like I feel like some of them can do it, but the others maybe will need the counters to be able to have like the 4 children that were playing first, and maybe they add 5 more to see how many are playing all together. That is how I think.
Right? Yep. So they might do it mentally. They might add 5 more. So let's all try it. Everyone, hopefully people have something that they can use as counters. So let's try it. So let's try the first method, which is what we would call count all. Okay, so thank you. I love to see the counters. So let's count all. So there were 4 children playing football. So everyone, let's get 4 counters. If you can turn on video, that would be great. Thank you for those that can. So here's these 4 children playing. And now what happens next in the problem?
5 more children join.
5 more. Okay, so let's get 5 more children. 1, 2, 3, 4, 5. So we have 4 and 5. And now let's put them all together and go ahead and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice demonstrations. I like this. And Evelyn, how many do we have all together? We have 9. We have 9, right? 9 altogether. Okay, now let's just try one other method. So there were 4 children playing football. So let's get again our group of 4 and 5. So we have 4 children, 5 children, and let's count on. So keep the first number in your head. So here's 4. 4, don't count 1, 2, 3, 4. 4, 5, 6, 7, 8, 9. So everyone try that so you can see what it feels like to count on. 4, 5, 6, 7, 8, 9.
But Yasmin, that means because I had 4 here and I want to add 5, it means I must also count 5 on its own to confirm it is 5. Then now I can do add on.
Yeah, so first you get your counters, right? You have 4 and you have 5. And then you're right. Then you count on. So you say 4, 5, 6, 7, 8, 9. So you do have to know that you have 4 and know that you have 5 first. This is it's a slightly more advanced counting strategy, right? What we want to do with children is encourage them to count all of them initially, but then we want to move them towards more efficient strategies relatively quickly so that they develop more strategies. So I'm going to give you another one here.
Go
ahead.
So before we go to that one, there are also those students who just have, like, say, 4 and then put a 5 in front and then say the number is 45. So about those, how do we handle those?
That's true. That say 45. So that's why I think it's helpful to have the counters, because you say, okay, show me 4, show me 5, and then count them. Right? You can't count these and get to 45. So you count them and you say, well, are these 45? Let's count them. 1, 2, 3, and you count by ones. And I think you go back to the counting whenever students make a mistake.
Mm-hmm.
Does that make sense?
Yeah.
Okay, so let's do this next problem. Musa had 7 bananas and he ate 4 of them. How many bananas did Musa have left?
So
Take, right. I'm gonna ask one of you to talk through it. How would you solve this problem? How might a child solve this problem?
I think maybe the child would count 1, 2, 3, 4, 5, 6, 7. And then from that bunch of 7, then count out 1, 2, 3, 4. And those who will get it correct would say 3, the ones that are remaining in their hands. But then there are some who would say 4 after they've counted 4. So that might be a mistake also coming from there with the sticks.
Yep. Great. Thank you. Yeah, those are great strategies, and also anticipating some errors. Is there another way a student might solve this problem other than taking, 4 away and counting what's left? What's another way a student might solve this problem?
The student could count back. They have the 7 counters.
Mm-hmm.
And then they count backwards from 7, 6, 5, 4, 3.
Yep. 7, 6, 5, 4, right? Take away the 4, there's 3 left. Exactly. Thank you. So students often count backwards too, right? They associate subtraction with counting backwards. So you could also count backwards. It's a little bit harder, right? It's a little more complex of a strategy, but it's just another way to solve this problem. Okay, any questions, comments?
I have another version, Yasmin.
Okay.
This is a dangerous one. Because I know we have this kind of learners also. Now, we are talking about 7. So I'm seeing a category of learners who might count 1, 2, 3, 4, 5, 6, 7. Now, the child will tend to understand that this is the 7 bananas we are talking about. But then I ate 4. And the child may not be able to relate that the 4 that he or she ate were from the bunch of the 7. So the child will come still and count. I ate 1, I ate 2, I ate 3, and then I ate 4. So the child had 7 here, but believes that what he or she ate was not from this group of the 7, but he ate 4 from somewhere else.
Mm-hmm.
So you are likely to find a child who, in such a scenario, instead of taking away, may end up putting together.
Yep. Very, very true. Yes, this is, again, children that may not have understood something about the problem, and they see the numbers, they think, oh, I ate 4 more, let me put them together, let me add. Very, very common. Yes, go ahead, Virginia.
Yeah, thanks, Bushnell, for bringing that up. I also sometimes want to connect that kind of children's thinking to their developmental stage, because this is a season when children are very self-centered. And especially when you're talking bananas and eating them, they are not very happy when their stock of bananas diminishes. So as simplistic as that reasoning could be, it's some of these challenges that children go through also are connected to their developmental stages and their cognitive shortcomings.
Yeah. Yes, thank you. Joy, go ahead.
Yeah, I also think that there's something you said about addition, that when the children are taught how to add, they form the 2 groups, then they put them together and then count all. But then they should quickly be moved from that to counting on, starting with the original number and then counting on. So if that doesn't happen quickly enough, then children think that every time you have 2 numbers, you always form the 2 groups and then remove the other group in subtraction. So they'll have 7, then they add 11, and then now they add 4, and then now remove the 4 that they ate. So they still end up with the 7.
Yep. Yeah, definitely. Those are all very common misconceptions. And, if this is one of the hardest things, I think, for teachers, but as we're all thinking about this, the students making these mistakes is actually, in math, we call them misconceptions. It's actually a great source of teaching, right? You want a child to make mistakes because then you talk about, well, why did you get 11? How did you get 11? Okay, let's think about it. Does that make sense? What problem did you solve? You actually solved 7 bananas and then 4 more bananas, right? Let's read the problem again. So there's all these ways that teachers can help the student think about, how did you get that answer and why? But I will say that's something, going back to the point, Virginia, you made, is the challenge is you can't really script that into a textbook. How do you get teachers to do that, to be comfortable with mistakes, all of that? It's pretty difficult. So I would say that, but I would also say in math, children's errors are one of the best ways to teach them, is to use their mistakes to think about how they solved a problem. I mean, that's what we're doing now, right? We're thinking about the errors, and then we're thinking about how we would solve those errors. That's a good way to help a teacher get insight into what a child is doing. So I'm going to keep going if everyone is okay, unless there's more questions.
Not a question per se, but then the comment would be this: on the counting forward, or some might count extra. Say those who have forwards might count 4, 5, 6, 7 to get 4 rather than 3.
Yeah. Oh, if you're counting 4, 5, 6, 7, counting up to.
Yes.
Yeah, that is a great strategy for subtraction. It comes a little bit later, but you're right. Students may say, well, I know they ate 4. I mean, basically, if the problem is 7 minus 4, one of the ways to solve that is to turn it into an addition problem. 4 plus what equals 7, right? That's what they're doing. So they're saying 4, 5, 6, 7. I added 3. Right? That's actually a very good strategy for solving subtraction, but it's much harder. But we want children to get there. So let me just show you guys this, because I think this will show you some of the progressions of the strategies. So when we're talking about single digit addition, there's 2 different ways to think about addition, right? So there's understanding addition is combining 2 sets, which is what we did, right? That's what we did right now. Here's, 3 kids playing football. Here's 2 kids playing football. Put them together, we have 5. So one meaning of addition is to put 2 or more groups together. The other one is thinking about addition as increasing an amount. It's a different way to think about addition, but there's also this idea that you have 4 of something and you add to that group. You add 3 or 2 to that group, and now how many do you have? And those are different, right? So you could think about, I have 2 different sets and I push them together, or I have 1 set and I'm increasing the size of that set. And we want children to do both types of problems. They don't need to know the distinction, but just so we all know, there's 2 different ways to think about the concept of addition. And then we think here, we want them to count all. We also want them to add by counting on. So this image shows you the 2 different types, right? You count out a group of 4, you count out a group of 3, and then you start counting 1, 2, 3, 4, 5, 6, 7. And the other one is counting on, right? So you keep 4 in your head, and then you add 4, 5, 6, 7. You can do it with counters, you can do it with fingers. Doesn't really matter. It's just 2 different strategies. And I will go to, let's see, what time are we at? Okay. This is what the beginning strategies for subtraction. Oops, I didn't move it yet. Here we go. There's 2 different ways to think about subtraction also, or probably like 3 different ways. So you can think about subtraction is decreasing an amount, right? So I have 7 bottle caps. I give my friend 3 of them. How many do I have left? Or I have 7, the one we just did. I had 7 bananas. I ate 4 of them. How many do I have left? So you're taking an amount and you're decreasing the amount. But another way to think about subtraction is as a difference, right? How many more or fewer one set is. So here you're really comparing sets. This is difficult for kids. It's harder. But something like, you have 7 bananas. Musa has 7 bananas. John has 3. How many more does Musa have than John? It's harder and the language is more complex, but we need to expose students and children to these types of problems at the beginning, right? You don't want to leave this until 3rd grade or 2nd grade. You want children to have flexibility with understanding what does it mean to subtract. You can decrease an amount, but you can also compare, Virginia has 5 pens and Walter has 6 pens. How many more does Walter have? That's a different type of problem, but it's still subtraction. Does that make sense? All good? Okay. And then I would also ask,
Sorry.
I would also say, oh, go ahead. I think somebody had a question.
Sorry, Yasmin.
Please.
Yes. I would think that that will make sense if the children are told that in their first language, because in English that sounds very difficult. But if it was said in their, in their first language, then it would make a lot of sense to them.
Yeah, definitely. I mean, in general, the more that you can help children understand the language of mathematics in their first language, the better. Not always possible, but better, especially for things like word problems. Because they're hard enough without understanding, even if you understand the language, they're still difficult. And just a few ways to think about subtraction, what children learn. We talked about subtraction by taking away, right? So you have 6 objects, you take some away, how many are left? We talked about counting back. I think we shared that methodology where you can take 6 and count back 5, 4, like that. And then the last one, which we had also discussed, was counting up to. Right, so 6 minus 2, you start from 2 and you count up 2, 3, 4, 5, 6, and you get 4. So these are the strategies in order of kind of increasing progressions and difficulties, right? So subtracting by counting up to is more difficult than subtracting by taking away. Okay, any questions about what children learn in some of these progressions?
Well, a quick one on the counting up to. What would be the most appropriate grade to do that?
These are first grade. First grade. Basically, you want, most of your single digit addition. So like addition up to 10 or addition up to 20 with just 3 plus 5, 6 plus 5, single digit addition. All of these strategies are in grade 1 because what you're trying to do by the end of grade 1 or by, middle of grade 2 is build up your fluencies. So what you're trying to do is you teach, part of the reason of teaching all these different strategies is because the more strategies you know and the more that you try, the easier it is to get to fluency because you build different ways of thinking about numbers and combining and separating numbers. So it leads you to fluency. What you don't want is in grade 2 for a student, if you give them 2 plus 3, to have to use a strategy. You want a student, by the middle of grade 2, you want them to know that 2 plus 3 is 5. You want to move towards automaticity. Which is why we spend so much time in grade 1 on basic addition and subtraction.
It appears very sophisticated.
It is, but you'd be surprised. Students are, usually, I mean, honestly, strategies like counting all is really more of the work that should be done in pre-primary or before grade 1, right? Because that's something that students are probably already doing in their everyday lives. So some of these strategies they're going to come in with. So speaking of that was a good question, Virginia, because we're moving into this, is to think about what are these different strategies for solving addition and subtraction. And I've named them here. You don't really have to name them, but what you're trying to do is get the students to move from diverse counting strategies to mental strategies to automatic recall, right? Even in grade 1, after this has been introduced and students have an opportunity to use counters, you want to move them away from using counters, right? You don't want them to keep using the counters to solve 2 plus 3, because then they're just doing it, right? You want them to start moving to the more complex strategies. So here is just a very basic progression for thinking about these strategies. So we talked about count all, right? Addition facts, this is for addition, but mainly for represented by objects. So 4 plus 3, you take 4 objects, you take 3 objects, push them together, count, or this could also be for some kids drawing pictures, right? We know students draw sticks. Maybe at some point they move to drawing sticks. We talked about counting on, right? Which is where you take the first number, 5 plus 3, and you say 5, 6, 7, 8. We talked about counting back and counting up. So all of those are counting strategies, right? Counting all is more the concept, and then counting on, counting back, counting up to are the counting strategies. After you finish those, you want to move students to the mental strategies. And we call these mental strategies or non-counting strategies. So for something like doubles, students, for some reason, it's very easy to get the doubles, like 3 plus 3 is 6, 8 plus 8 is 16, 5 plus 5 is 10, 2 plus 2 is 4. If you talk to young children, a lot of them already know doubles because it's just something that's easy to remember. Some more complex strategies are something like doubles plus 1, right? So 3 plus 4, in my head, I could say, I know 3 plus 3 is 6. Add 1 more, I get to 7. Right? So what you're really, if you remember what we talked about yesterday or last week with composing and decomposing, you're really trying to get kids to use some of those skills and use what they know about numbers and apply it to addition and subtraction. So these are just some of the strategies. Doubles plus 1. Make a 10 is a great one. Students love the number 10. It's a very easy number to operate with. It's an easy number. We really want to talk as much as possible about 10 because it's just such an easy number to use. And so if you're doing something, this is 7 plus 6, you might say, well, I know 6 is 3 and 3. 7 and 3 makes 10. 3 more is 13. These are the types of thinking we want students to be doing in grade 1. And then if you do all these strategies and you give kids lots of practice using these mental strategies and talking about it and sharing how they solved it, that's what gets you to automatic recall. That's what gets you to just knowing. If you do 7 plus 6 over and over and over in different ways, eventually your brain just says 7 plus 6 is 13. And it moves into the automatic recall part of your brain. Any questions? Or comments? Concerns? No? Okay, I'm going to keep going. Because now what I'm going to do is ask you all to lead a math talk with one of these strategies. So I will model it for you. Basically, what you're going to do is, oh, do we have a question? Great strategy. Okay, thank you. Sometimes with these types of strategies, like doubles plus 1 or any of those, it's difficult. Sometimes you have to teach this strategy to a student because they may not know. So what we're going to do is do a quick activity called a math talk. You have this handout in the Google Drive also, so you can download it and use it. And what we're going to do is model this structure. So you pose a problem. You ask the students, here's 1 minute, solve the problem yourself. Then I'm going to say, turn and talk to a partner, which we won't do here because we don't have, it's too hard to do. Unless you have someone at home you can turn and talk to. And then I'm going to ask a few people to share their strategies. And then we'll summarize the strategies and talk about a new way to solve the problem. Okay, so I will model this one for you. So I'm going to stop sharing for a minute so you guys can see me. And I'm going to see if this works. Can you guys see my whiteboard here? Okay.
Yes.
Yes. Okay, great. Let's see. Okay, I don't know if you can see that, 7 plus 8. Do you see that? Is it backwards? No.
It's clear.
It's good. Okay.
It's
looks
clear.
Backwards to me. Okay, great. So 7 plus 8. So I want everyone to take 1 minute. Let's not use counters. So just think about it and think about one way you could solve this problem. And let's pretend you are first grade students. Okay, hopefully everyone has found a way, has thought about it. No counters this time. So Peter, no counters. This is all just mental. Can somebody share one way that they solve this problem? Who would like to share? Anne, go ahead. Thank you.
Thank you. I used the formula addition as before. I doubled 7, and then I went ahead.
Wait, hold on. You doubled 7. So what do you mean? You did 7
plus 7
plus 7. Okay, which is
14.
Okay.
And then I went ahead to add 1.
Where'd you get the 1 from?
The 8 now. On the 8.
Okay.
So now on the 8, removing the 7, I added now the 1. I did double of 7, and then now I went ahead to add plus 1 because 8 is near.
Okay, because 8 is 1 more than 7.
Yes.
So where did you add the 1 to what?
To 14.
To the 14. So you did 14 plus 1, and you got?
15.
15. Okay, great strategy. Thank you. Does somebody else want to share a different way they may have solved the problem?
Hello, Yasmin.
Yes, go ahead.
I think I have a little input.
Okay. Go for it.
The first you hold 7 with one hand, so you don't count.
Okay.
You hold 7.
So you hold 7 like this.
Yeah, one hand 7. Yeah, you don't just like a fit. So that's 7.
7.
Then, yes, and then there you add 8. You count 8. From 7, you have 8 on the other hand. Then you say 7. That is 7, 8, 9, and then you have to come all the way to 15.
So let me see if I got this right. So you go 7, 8, 9, 10, 11, 12, 13, 14, 15.
Yes.
Is that right? Okay, great. So you started with 7, and then you counted 8, 9, 10, 11, 12, 13, 14, 15. 15. 11, 12, 13, 14, 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 15. 1, 2, 3, 4, 5, 6, 7, 8. Okay, great. Thank you. And let's do one more. James?
Thank you. I will take 8 and make it add 2 to make it 10 because it's much easier to add with a number with a 0.
So 8, how did you get to 10?
Then I break 7 to 5 plus 2. So it becomes plus.
So then you did 8. Okay.
Then I'll add 8 to 2 to make it 10. Then now from there it becomes easier to add the 5 to make it 15.
Where did you add the 5 to?
It can be counting on. I can use counting on from 10.
From 10, okay. So, or you could just do this, what you said, 10 plus 5. 15.
Yes.
Okay. Great. Thank you. Great strategies. Okay, everyone. So today we heard lots of different strategies. So students, what I want us to focus on today and what I want you all to try is something that we heard from Anne called the doubles plus 1. So what this does is we know that 7 plus 8 are really close together. So we could use, and I know in my head, I already know 7 plus 7 is 14. I already know that. So I know that 8 is just one more than 7. So I'm going to kind of do this where I say it's 7 and a 1. I add this 7 to this 7 and I get 14. I have a 1 left over. I bring it down here. 14 plus 1 is 15. Let me show you one more way to do it. So with the 8, I could also say 8 plus 8, I know is 16, right? I already know it's 16, but this one is not 8, right? I had to add 1, so I had to do 7 plus 1 is 8. So now I have to subtract the 1. So I have to do 16 minus 1, and I get to 15. So that's doubles minus 1. But basically, we want to use the doubles. So what I'm going to ask you all to do now is try to use that same strategy to solve 3 plus 4. Okay, use the doubles plus 1. And now I'm going to stop here. So that was the end of the demonstration. What I want you guys to do now in your breakout rooms, and I think we're going to have, let's see, let's do 15 minutes in a breakout room. And what I'd like you to do is to do this. So be the teacher. You might have to use either like something, I don't know, you could use a Word document to write it and share your screen, or just hold up a piece of paper or something. Really important to document it on the board, right? If you noticed, if I just talked, it would have been much harder to follow. You want to make sure the teacher, you're writing it on the board. But I would like you guys to teach a strategy. You can do doubles plus 1. You can do doubles minus 1. You can do make a 10, as we heard from James. That was a great strategy also. Any one of those. And I would like you all to take a turn and try to model a number talk. Lydia, question?
Yeah, thanks so much, Yasmin. I'm wondering, the assumption here is that the learner already knows, like, it's like they already know multiplication. Because it's
probably
like
not multiplication.
Yeah.
But go ahead.
Because like, okay, maybe the learner knows 3 plus 3 is equals to 6. But I'm imagining that the learner knows 8 plus 8 equals to 16. It means they're operating at a very high level that they don't need to break it down.
Yeah, no, you're right. So what we're assuming here is that you have, you know, again, going back to that progression, right? You start with if we go back to this, you've already gone through this progression, right? So you started with the concept, you moved to these counting strategies, and now you're at the mental strategies. And it may be that some students know their doubles. If they don't know their doubles, the doubles plus one fact doesn't work, right? Then it's not a great one for them to use. Maybe they should try to make a 10, or maybe they know that 4 plus 2 is 6 and one more is 7, right? What you're trying to do is get students to learn these different types of strategies, different ways of combining numbers, right? But we do, again, in grade 1 and the beginning of grade 2, we do want students to move towards these mental strategies. We don't want kids to be counting all or using counters to add addition and subtraction facts, especially something like 3 plus 4. Does that make sense, Lydia?
Yes, Yasmin, thanks.
Okay. So I think we can go ahead and do the breakout rooms. I see we're getting ready. We already have paper posted. I'm excited to see that lesson. So go ahead and join your breakout room, and don't forget to download the directions.
think we're all back. We lost some 4 people along the way.
Whoops. Any reflections on that activity, on how it felt to try to get people to explain?
Maybe Virginia can finish the one here she had started while we were on the breakout, so that.
Yeah. Go ahead, Virginia.
Yeah, my reflection, thanks Walter, thanks Yasmin. My reflection was around the language. And how much of the mastery, even in terms of expression, for a learner to be able to say that 4 is indeed 1 more than 3. So I think it is one of the things that I took, the fact that there needs to be a lot of language developed before the children can make use of this strategy. Then the other one is around the step-by-step process. I think looking at how we did it in our group with Teacher Bushnell, it was slightly different compared to even how the demo was done in the main lesson. So we even showed how we broke apart our 4 to get a 3 plus 1 and eventually worked it out. Yeah, so those are some of the dynamics one has to take care of in the process. But I had a question around when would be the most appropriate because to use this strategy, especially given that it is really relying a lot on the mastery of operations because we already have operations within it. It seems very much oral in the way it is meant to be introduced, but also it has it requires some level of understanding of the mathematical science that will be applied. So how do you strike that balance to be able to build the facts, but at the same time to be able to have introduced children? Because I'm looking at our curriculum designs and I don't seem to see number families anywhere unless maybe they are within the unpacked textbooks, but we move from modeling the addition as putting together, we move to the interpretation of signs and then adding two single digit numbers and 3 digits. I mean, it goes to the vertical algorithm, if you may like, without necessarily having to go deeper into the number family issues and the doubles and the number facts that are necessary for this.
Yeah. Yeah, and that's an interesting question. So many curriculums go to the vertical algorithm way too quickly. In my, from what I've read, and there's been some good research out there that the vertical algorithm should be the last thing you introduce. Like you want children to be able to use these doubles plus 1, and now we're going to talk about more complex strategies just for 2-digit numbers without doing the vertical algorithm, right? You want to make sure that you've got the foundations that children know what they're doing. Otherwise, the vertical algorithm just becomes something to memorize. So, but a lot of curriculums, as soon as they go to 2-digit, they do vertical algorithm. I think that's very common, but I think to the extent that we can try to change it, to the extent that we can add in some of this prior work, which will, you can see even today, just doing things like we did doubles plus 1. If you were to make a 10, how that helps reinforce place value, right? All of these things are reinforcing some of these basic ideas about number and operations so that when you do get to regrouping and place value, which we'll talk about later today, it'll be really easy for the kids. There won't be this, what do I have to do? I have to carry the 1 and put it up here. It makes more sense to students. So I think that makes sense. And Monica, you asked a good question. Doubles plus one works, but there needs to be great mastery of doubles. So you're right. I mean, part of this also is if I am a child and I don't know my doubles, I probably won't use a doubles plus one strategy. Right. So doing more work with the doubles, building up those fluencies, I think is a good idea so that children learn some of them before. And sometimes they know some of the doubles, but not all of them. Right. But all of this, what we're really trying to do again is move away from counting, move away from using counting strategies and move to more sophisticated strategies. We know that children get stuck in the counting. We did this study, globally and looked at children solving problems like, I don't know if you can see this, like 13 plus 6. And you know what most kids did? This was at the end of second grade. They drew sticks and then they counted from 1, 1, 2, 3, 4. They were using a counting all strategy to solve something like 13 plus 6 at the end of second grade. So if you have trouble solving this one, what do you do with something more complex? I mean, we have to, I don't know if you guys can see this. Sorry, I used a light color, but we do have to get kids past this. We don't want to see sticks being drawn past, in grade 2, they should not be doing that. So I'm going to move us on with and we'll take a break shortly, but I just wanted to, so we did this. I wanted to do just what we're going to do right now. It's a little bit different, but it's something called problem solving. So this to me is a great activity to do with teachers. So if you're training teachers, you're working with teachers, sometimes teachers forget or don't know how it feels to solve problems. Like what we just did with the doubles plus one and trying to explain it. And I heard some reflections about how it's about language. It's about being able to clearly articulate what you are doing. Right. And that's hard. That's not always easy for a lot of teachers. So sometimes it's good to think about, let's problem solve ourselves. Let's have teachers solve some real math problems and explain it and think about how they explained it. So I'm going to show you a problem. And what I would like you to do is take about 5 minutes. You can use paper and pencil, whatever you want, and try to solve the problem. And then I'm going to ask some people to share their solutions and how they solved it. Oh, I think I just said this. Sorry. So solve problems. Teachers struggle with mathematics themselves, and engaging in authentic problem solving allows teachers to understand how learners feel. So it's a great activity to do with teachers. So let's pretend we're all teachers now. So here is your problem. You are building a straight fence that is 40 meters long. You need to place a post every 5 meters, including one at each end. How many posts do you need? So this is not a problem for students. This is a problem for teachers. So this is for you all. This is not for students. And then I have some follow-up. If the fence is 100 meters long and posts are every 4 meters, how many posts? And if the fence is X meters long. So go ahead and take, how long do you guys want? Maybe when you're ready, give me a sign, like raise your hand or something when you have the answer to at least the first one. Okay, so I already see some answers. Do most people feel like they had enough time? Or would you like more time? I already see two different answers. I see some people are saying 8, 10, and some people are saying 9. So we have two different answers. There's another 9. 9. So here's what we do. So we have some 9s and some 8s. So someone that said, or sorry, some 9s, some 10s. Does somebody who would like to explain? Because remember, this isn't just about the answer. This is, how did you solve the problem? How did you get the answer? And I also see an 8. So let's do the first one. Let's do 40 meters long, and you place a post every 5 meters. Virginia, share with us your manual process.
Yeah, I am 844, and I didn't seem to have a strategy for working out that one, so I had to draw my posts.
Okay, that's good. That's a good strategy.
I had to draw my posts and keep counting back and forward to make sure I wasn't getting lost in the 100. But
so how did you draw it?
I didn't have an outright tool in my repertoire of formulas to do this.
We all do it differently. I drew mine too. The first time I saw this, I drew it until I figured out the pattern. That's just the way I thought. But then I also see how some people put in something. So can somebody, Elizabeth, do you want to share yours? You were the first one that put 40 divided by 5 equals 8 plus 1 equals 9.
All right. If we have 40 meters, if you divide by 5, you will get 8 spaces. There will be 8 spaces of 5 meters each. But then the very last one, where there will be no, then there must be a last pole. So you have 8 spaces. Of course, you started from where you had 0. You had 1 pole, then measured 5, another pole, measured 5, another pole. Then at the end, if you have to put the last pole, then you'll have 8 spaces, and then you add 1 pole. That gives us 9. Thank you.
Okay. Thank you. Great explanation. So that's what I heard. But some of you did 40 divided by 5 plus 2. Who wants to explain that? Is it plus 1 or is it plus 2?
I was conflicted, and Virginia has called me out. Yeah, I was actually thinking that it's 40, then you start counting it, maybe at the end. And then I realized, actually, even for integers, maybe you start at the far end. So that means that we only had one end to fill. So it's the 40 divided by 5 and the one extra pole. And I think that also now applies for the second one, which is 100 divided by 4 plus 1.
Okay.
Making it 6.
So you think it's plus 1, but first you thought it might have been plus 2 because of each end.
Because of the 2 ends. But then I realized, and even for integers, when you start at 0, you don't start building a house by putting a pole in the middle. You start at the far end, and then you start adding to the end. So I'm shifting from the other team to Virginia's team. We're adding plus 1.
Okay. Okay. Does anyone want to argue for 10 as the answer?
would have been good to hear from Roland and the sabotaging. I think he was sabotaging this one also.
Yeah, I was sabotaging Virginia. Yeah, I think I've shifted. I like that analogy by Walter, that when you start building a house, you start at a point, and your pole must start from. So with that, I realized there was only one pole remaining at one end. So I'm shifting to 9 instead of 10.
9. Okay.
Initially, I started from building in the middle. Then I left 2 edges. But I feel like I need to start from the start, then end. I bought that idea.
Okay, great. Great. Yep. So you guys are correct. Oh, Lydia, go ahead. You were going to say something.
No, I just wanted to make fun of Volan. He was using old knowledge that he knows 40 divided by this.
Yes.
Exactly, right? Because it's 40, you divide it by 5, and then it says 1 at each end. So you think 2.
Yes.
And then you just add 2. Exactly. So can somebody tell me the last one? If the fence is X meters long, how many posts are there? What's the formula? How would we write that? How would you represent it? Go ahead, Joy, explain.
If the fence is X meters long, that is the length of the fence, and there are 4 meters between the posts. Then we have the first post is right at the end, and we keep adding a post every 4 meters. So the total number of posts will be X divided by 4, the total length divided by 4. But then at the end, there is no post, so we need to add 1 more at the end so that we have posts all along the fence.
Perfect.
Yeah.
Yep. Thank you. Got it. Did everyone understand her explanation? Was it clear?
I thought the plus 1 was coming in because of that additional instruction, that including 1 at each end. But this last one doesn't seem to have that framing.
Oh yeah, it should be. I think it's just assuming that they come all together, but you're right. Yeah, it is including 1 at each end. X's should never be found. Okay, everyone clear on how to solve the problem? You understood everyone's explanations? Yes. So again, when you train teachers, give them some real problems to solve and have them talk it out. There's different, what we just did where we had some different answers. At no point did I say, oh, you guys are all, you're right and you're wrong, right? And then I explained it. I didn't explain anything, right? You all explained and convinced each other. That's the type of dialogue would be great to get in the classrooms, but that you want teachers to get used to. You want teachers to, argue with each other and say, no, but it's only a Post-it, 1 at each end, but this one's included. It's only +1. It's not +2. And you want, what you all did, like Virginia, you held up your paper and you explained how you did it. That's what we want children to do. That's what we want teachers to do with children, right? So this process and getting teachers you're not saying, here's an easy problem to solve and pretend you're a child. You're basically saying, here's the problem, go solve it. So this type of work with teachers, I think, is actually very, very important. So the more you can do this with teachers, the better. Yeah. Any questions or anything? Or maybe we should take a break and then we'll come back and discuss a little bit more. So let's take this was a long session, so let's take like a 10-minute break. And then we'll come back at, I think it'll be your 7:10 or 7, not 10, 707. Okay, see you in a minute.